that said, my name is Billy Korando. So I kind of changed the name of this presentation late. Initially, the name that's out there and maybe in a couple of areas, it was originally forward to Java 18 and beyond, but I decided to change it to how Amber is driving Java's evolution. And if you don't know what Amber is yet, that's fine. I'll obviously get to it. But I think it better captures what I'm going to be covering in this presentation, which is primarily focused just on the new language features coming. Some important notes. Ask questions, though. I guess, I've been so used to doing virtual where usually time slot's a little bit more generous. So we'll see. But definitely, if nothing else, ask questions after or at the end of the presentation. I'll be more than happy to answer them. But we may even have time for questions during the presentation as well. Definitely reach out. Reach out to me at Billy Korando on Twitter, where I spend way too much of my time. You can DM me or just tweet at me, and I'll be happy to answer any questions you might have. Or you can also email me at billy.korando@oracle. And the link to the slide deck is at that GitHub link, so you can definitely go and check it out there for any thing you want to go back and checking out. So you leave with an intense desire to know more. The team I'm at, the Java DevRel team at Oracle, we have a lot of great channels for learning more. We have dev.java, where we have a bunch of great tutorials, as well as links as how to get more involved in the community, so like upcoming conferences, local Java users groups. So definitely check that out. There's a really great Java users group called Atlanta Jug here, if you haven't been to it. We also have the Inside Java, which gives an idea of the developments going on within OpenJDK, which also has the Inside Java podcast. Every Monday I do a Sip of Java, a 1-minute video that I post up to Twitter on various Java topics. And then we have our YouTube channel where we do the Inside Java newscast. And my colleague Jose, he does his JEP Cafe, which are deep dives on JEPs and also other Java content. All right, so Project Amber, from the title of this, is the goal of Project Amber is to explore and incubate small productivity language-oriented features. Project Amber is one of many or several active OpenJDK projects. There's also Project Valhalla, Project Panama, and Project Loom. And it's like, okay, I can kind of understand, how these names came about. So like Project Valhalla, well, it's about improving the memory map for Java, which particularly is including our introduction of value types. And so value types, that's often defined as val within a language. So, well, Project Valhalla. All right, Project Panama. Well, that's about improving the interface between the JVM and native interfaces. And the Panama Canal famously connects the Atlantic and Pacific Ocean. So the Project Panama is connecting two oceans, metaphorically speaking. And so that's how we get to Project Panama. And of course, Project Loom, probably one of the projects most people are excited about. It's about improving thread handling, or particularly the introduction of virtual threads, along with a few other things within Java, of course. Looms are about weaving threads together. Okay, well, thus Project Loom. So when I heard Project Amber and how Project Amber, or as I learned about, is introducing new language features, well, a lot of times on Twitter and other places, people like to joke that, Java is just behind, it's finally implementing features, all that stuff. So I thought it was like a bit of a tongue-in-cheek reference to Java being stuck or kind of being fossilized. And well, even one of the Duke images created for it kind of has Duke stuck in amber. I was kind of thinking Jurassic Park and stuff like that. But that's actually not what the story behind Project Amber. It's way more dorky. So there's this book the series of books back from the 80s called The Chronicles of Amber. And why this was chosen is there's a ritual passage called Walking the Pattern. And pattern matching will be a very important concept within Project Amber, which we'll talk about here in a few moments. But yes, indeed, the OpenJDK project is run by a bunch of nerds. I even say that as another fellow nerd. I'm like, wow, this is way more of a deeper dive than I was kind of expecting. So on Project Amber, again, it's about providing new productivity-oriented language features of Java. And there's a couple of other changes that have already been delivered by Project Amber, local variable type inference and text blocks, which I won't really be touching on. They're really great new features, but it's not quite within the story I want to talk about here of Project Amber. So with that said, the agenda for here is we're going to be looking at some key language changes between 11 and 17. The themes of these language changes, like what's the larger story? Is it, it's not just a bunch of scatter stuff that we're kind of doing. There is an actual theme to what's going on. And then we'll actually get a bit into the future of what's coming for Java as far as new language features. So let's quickly review some of the key language changes introduced. We'll look at the updates to Switch, pattern matching for instance of, records, and sealed classes. So Switch updates, these were added in Java 14, and then I also put on there JEP 361. Now, if you're not familiar with what the JEP means, that stands for JDK Enhancement Proposal. So whenever there's a somewhat substantial change added to the JDK, it goes through this JEP process. It's about, and what these JEPs provide is some really great background information, like the motivation behind why this feature is being added, some history, and then also for particularly language features, how this feature would actually be used. So this is some great information, and definitely check it out because it will kind of provide a lot more depth than I could really provide for each of these features during this presentation. So of course, with the updates to Switch, we're all familiar with the colon syntax for Java, where you list out all your cases, colon, and then you would put whatever kind of behavior you want to have, and then you have to end it with a break. And it quickly becomes a lot. Here in this 7 cases, it's defined in about, I guess, 23, 24 lines. But it's just difficult to read because really, there's about only 2 lines we really care about, and then we have to add these breaks. So it's just a lot of noise within here. And then between that then is that there's also a lot of opportunities for introducing a bug, which is like you could have been working on your code, refactoring it, or adding some new cases, and you might have accidentally removed a break, or if you get to add a break, and maybe in your unit testing you're covering 4 or 5 of these cases, you're kind of maybe doing some spot checking on it, but you didn't test case 6, and then you get out to production, it matches on case 6, and now you fall through to case 7, and so you quickly introduce a bug. So it's not just, a lot of these features, when we talk about productivity, it's not necessarily just about reducing the amount of typing, but also reducing the ability to accidentally introduce bugs. So Switch updates introduces several new changes to Switch, or new enhancements to Switch. The first is the new arrow syntax. And so with this, it's obviously much cleaner. And so how it works is you match on a case, and then only the code to the right of the arrow is executed. There's no longer any sort of fall through when you're using the arrow syntax for a switch. So again, it makes it both cleaner, but then also less error prone as well. You're not going to accidentally fall through to another case when you're not expecting it, just because in the end, fall through by default is relatively a rarely done thing when using switches. You can also write switches as an expression. So that's maybe also a little bit confused. At least when I first read the JEP, it's defined as switch expressions, but it's actually more of a change than that. But so with switch expressions is you can then return value or yield value out of a switch. In this case, I'm just returning the string value of the day of a week. Now, switch expressions, they must be exhaustive, which often will mean then you will need a default case like I have in this example. And then in this example, I'm throwing an exception. But of course, you could also just return a string value or whatever appropriate type-specific value that would make sense as well. Which switches are the updates to it? With the arrow syntax, you can also execute a code block, like in this example, so that way if there is, for some sort of case, a more complex behavior you want to go through, then that can be covered in just a single line, you can do that as well. When using it as an expression, then it must end in a yield statement, and that will then yield that value back out, or a throw, or there's, I think, one other one, but yeah, so it needs to end in a yield or a throw. Within it, there needs to be some sort of value or exiting out of that execution from that case. However, this behavior, the ability to write an expression, is also applied to the colon syntax. So if for some reason you still want to use the colon syntax, you can do that as well, as in this example of doing yield from a colon syntax, or writing a switch expression as with the colon syntax. So as I mentioned, most of the time you will need to have a default case when writing a switch expression. But if, for example, at least really right now, this is about the only example as of JDK 17 when you wouldn't need a default case when switching over an enum. If you cover all the different values within the enum in your switch expression or your switch case or switch expression, then you don't actually need to provide a default case. And of course, that will also apply to the colon syntax as well. So pattern matching, as I mentioned, and kind of as it was alluded to with the story behind how Project Amber got its name, pattern matching is going to be a very, very, very important story going forward within the Java language and, of course, Project Amber. And the first example of pattern matching is pattern matching for instance of. Again, this was added in JDK or Java 16, and the JEP for that is JEP 394. So we only occasionally use instance of as developers, but you're kind of working with some sort of value that may be coming from an external source, and you need to, and you don't know exactly what type it is. So you need to do a check like, okay, is this object that's actually a string clearly? Is it really an instance of string? Okay, it is. Then you assign it to some sort of variable, and then you have to do the cast still on it, and then you can actually work with it. Again, to kind of follow the theme of like what we saw with like switch, there's some opportunities to accidentally introduce bugs in here. In this example of just checking against one type, it's maybe not as clear, but if I have to have like multiple types in here, it's like, is it a string? Is it a number? Is it an integer? Is it something like that? Then there's kind of like those opportunities and kind of and all that if else, if else, if else, to maybe accidentally introduce a bug. And if nothing else, it's very noisy to look at. So instance of had, or pattern matching for instance of has is that, okay, if this is actually a string, then assign it to now I'm a string, and then we can use that now I'm a string variable. And so this is what pattern matching is. You have a predicate, a test. Is actually a string, and if it's true, then we assign it to a pattern variable. Now with this comes a new concept, or at least something that's more relevant now, which is called flow scope. And what flow scope is that this variable, now I'm a string, it is in scope wherever the compiler knows it has been set for sure. So what will this often mean is, okay, now I'm a string is in scope, obviously within the evaluation statement or evaluation block, and then it's going to be available also within the if statement block. But once we leave that if statement block, it's no longer in scope, because now the compiler doesn't know here, it doesn't have to have been evaluated true for it to get to executing here. So this would then be out of scope. And then also we can see here, if I just had an evaluation here and had my pattern variable, it would still be then out of scope outside of the evaluation block. You can get a little goofy and weird with it. So if I was to do a not here, in the else of the if else, it would be in scope, but it wouldn't be in scope in the if. Or here in this if statement, I put a not around it, and then I threw an exception that, oh, this must be a string, then it would be available outside the block of the if statement, because of course the code can only get to this point if this evaluates a false, thus making mean this is true. This is to really demonstrate just what flow scope is. Don't do this in code, because this would obviously be very error prone and very confusing to read, but this again, just showing what this new flow scope, kind of how it would actually work. And it'd be very relevant then to other areas where we'll see pattern matching a bit later. Records are probably one of the biggest changes being added to Java. I kind of view since Lambdas. And they were introduced in Java 16, and their JEP is 395. So probably the first way developers will really see the benefit of records is reducing verbosity. And I know the text on this is really small, deliberately so. So like imagine we just have some sort of method in here that we're doing some like data transformation on. And we need just to have some sort of like throwaway class in there to kind of handle it, to do whatever work we want with it. And then it doesn't really make any sense outside of that method. Certainly, I know I've done a lot of ETL at several points in my career, and something like this would have been very nice, to where I could just define a class or record just in a single line here, and we get all the benefits we need. Just because even defining the most simple of classes often requires dozens of lines if you want to be able to have like equals, a hash code, and accessors, and along with that. So records greatly reduce the need for when it comes to writing just data carriers. But that isn't the point. That wasn't the point in design when writing records was to reduce verbosity. The goal was to be better about transparent modeling of data as data. So when I defined a record on that previous example or previous slide, we can just look at the definition of the record and immediately understand all we need to know about it, its contents. We know its name, and then the components of the record were within the parentheses. That is then the fields that have been created for that class, and that is the only fields that can be contained within that class. So, and how we know that is that the record, it can only extend off a record. You can't have another record extend off another record. There's certain constraints that can enforce that kind of behavior. And it's like they can't be extended, they can't be abstract, and as a result, they're implicitly final. You can also, all the fields are also final as well, but of course they're shallowly immutable. So if one of those fields was an array list, you could of course add or remove items from an array list, and that won't be prevented by a record, but you probably wouldn't want to do that. You would want to use an immutable list type when working with a record. But also, you cannot declare any instance fields or field initializers or instance initializers when defining a record as well. So like I couldn't then, in these curly braces, add like another additional field that, was like string middle name that was, also initialized to an empty string, or I can't initialize like Twitter handle to be an empty string either. Also, the compiler will automatically generate accessors, hash code, toString, equals, and these can also be overwritten. For how the accessors work with records, they don't follow the Java beans syntax of like the get, and of course set isn't relevant to a record because you can't change it. But what they just use is just the field name itself. So to access like first name out of this record, it would just be like the name of the instance dot first name or dot last name or dot title. But fundamentally, records are just classes. They just have a number of constraints on them. So like I said, if I wanted to, the toString, if I wanted to have some sort of prettier formatting for it to be printed out, I could override toString if I wanted to do that. We can also add additional constructors, but they do all have to call the canonical constructor as well. Is also something you can do. The last change that's been added I want to cover is sealed classes, and those were added with Java 17, released just over 6 months ago with JEP 409. So what sealed classes allow you to do, or at least one particular benefit I see them to do, is like they allow you to define hierarchy and relationships within your model, where it wasn't always possible before. And certainly at all of our organizations, we have certain domain classes, and you may have like some sort of a superset, and then that subclasses, there may be like some sort of limited changes for or types up within it, and that wasn't ever really possible before to model that in Java. So imagine like here in this example, I have like a user, and from user, okay, we could have 3 different types of users within our system. We could have a guest, a customer, and an admin. And maybe within admin, there could be 2 different subtypes as well. What sealed classes do is allow a class to define what classes can extend upon it. So in this case, these different outlines for the objects kind of represent the different types. User is a sealed class. Guest would be a final class. Customer, non-sealed class, which effectively makes it a normal class that they can be extended by any other class. And an admin itself would then also be a sealed class as well. What does this actually then look like in code? So you would then define the class. You would have like your modifier, or for like in this case public, and then you would use the new keyword sealed, and then your class name. And in this case, permits, it's an optional argument. And here I'm then defining which classes can define off of user, in this case, admin, customer, and guest. Then these subclasses of admin, customer, and guest, they must then declare whether they're going to be sealed, like in the case of admin, final in the case of guest, or non-sealed as a case of customer. And a non-sealed class, again, effectively makes it a normal class to where any class can then extend upon off of customer. So as I talked about before with records, they can't extend any class, but they can implement interfaces. And so a great way you can use sealed classes and records is through interfaces. In this example of a user sort of interface, and where then each admin, guest, and customer implements user. So as I mentioned earlier, the permits clause, wrong way. The permits clause is optional. If you're going to be referencing classes outside of the source file of this sealed class, then you use the permits clause to say, okay, these classes can be extending off of it. However, in this example, this is like all within the same source file. If you do a sealed type, whether interface or class, and you define the other classes within that same source file, then that is then assumed by the compiler the classes that can then be extending off of that class or interface. And those are the only ones that would be needed. And in that case, a permits clause is not valid, and then the only classes that are allowed to extend off of it is the ones also defined within that same source file. But yeah, so far, this is what has been delivered by Project Amber, var back in JDK 10, and then var for lambdas back in 11. And so also since then, since those two features, we have followed a path of there's at least two rounds of preview before a feature becomes standard, and that allows the community to be able to get a chance to give feedback on these new features and allow them to be improved upon. And we've seen a lot of benefit within that. Certainly not on here, but something that's going to be coming pretty soon is pattern matching for switch, which I'll also be talking about. It's actually entered a third round of preview for JDK 19, and that's again because of the feedback that we got from the community on how it could be better improved upon and used. And certainly between all these features, there's often some amount of changes between preview 1, preview 2, and then it becoming standard. So I think that's a great process to make sure that when these features are actually delivered and are actually going to be used properly in like more production or for real use cases, to make sure that they're properly tested out and we're going to be happy as a community, and then of course from our perspective as the stewards of Java, on maintaining these features on into the future, many years of the future of Java. But what are the themes behind these changes? Well, one is to be more expressive in how we write code. You know, we see kind of like with the switch, with the new arrow syntax, it's much clearer when looking at that, what we're trying to accomplish with that switch. Also, it's about being safer. We'll see in a little bit here, particularly with like pattern matching for switch, how we'll maybe get compiler warnings if maybe something in our code changes unexpectedly to make sure that you know, we're not accidentally introducing bugs unknowingly. Also about maybe potentially addressing some security concerns. If you're still, say, for example, doing serialization, records are a much better way of handling serialization that avoids many of the security issues that come with it. Also, pattern matching addresses a lot of concerns when it comes to handling with nulls, which we can also see a little bit later. but also, of course, reducing verbosity and ceremony. But again, that's not just about typing, but also reducing the opportunities for bugs, as we can kind of see with that example of like the break statement within the switch statement, where accidentally forgetting to add it can lead to a bug occurring. But also, Brian Getz, the Java language architect, also put it really well. It's about making it easier to program in plain data, reducing the ceremony, and just making it easier to work at those boundaries, which is becoming even more relevant as we move to, or as things like microservices are continuing to be somewhat popular, and also things like lambdas and serverless functions also means we're often more interacting at that data boundary a whole lot more often. All right, let's get into the future of Java. Oh boy. Okay, I don't know how that actually got in there. But keep in mind, the future isn't written, as Doc Martin famously said. It can be changed. So a lot of these features, there might be some changes at some point in the future. So don't necessarily look at the exact syntax of the code and be like, oh, well, hold on, Billy said, back at Devnexus, this was exactly what it's going to look like. It might change. And indeed, from the first time I gave this presentation to now, for example, switch patterns have changed a bit as well. I've updated in this example, but that's just an example of how things can in fact change. So the first I do want to talk about is pattern matching for switch. So currently it's in preview 2 with JDK 18. Soon it'll be a third round of preview, as I mentioned, and that's currently a draft JEP. So you can still reference to kind of see those changes there. And that reference, even after it's updated to, it's been accepted as a JEP, it'll be updated with a simpler number like 420 is, but that's still redirect even after then. So what pattern matching for switch does is exactly what we saw earlier with instance of for pattern matching, is now we have a predicate and a pattern variable. So we have a predicate of matching on a type of integer on a switch case, and if it matches on that, then it will be assigned to the pattern variable of I, and kind of like how with instance of, that pattern variable would be only available wherever the compiler knows it's definitely to be true, which would often then mean the following if block statement. In this case, the I would only be in scope only to the right of the arrow. So here, I is only in scope for here, and then L, if it's a long, it's only in scope for here, and then double, and so on. What's also being added then is the ability to do guard patterns, to where instead of, okay, like if it's like a positive number, I want to do something else, oftentimes then within the switch, I would have to do some sort of if statement to then do that check and do that additional behavior. Now we have guard patterns, which are denoted by the new when clause, and then to the right of that, you can do additional checks like, okay, if this case, if I is positive and I is even, then it will, it will execute this statement and, print out positive and even, and then the variable I will also be available if I wanted to print that out. Then, of course, I could do, I can check just like, okay, if it's just greater than, if it's positive, then it's positive and odd, and I'll also print it out. So what this is, the cases can't dominate. So if I try to switch this around to where I is greater than 0 and I is divided by 2, and I put that as a second case and with I greater than 0, that will give a compiler error, because obviously we can never reach that second case statement, because wherever this is true would be also the case for this being true. So cases can't dominate this following case. What we can also see here is I'm using the same variable ID of I for all of them, but again, as far as the compiler is concerned, this is all unique instances of I, because again, I would only be in scope to the right of the arrow operator. So that can also make it much cleaner than having to think up arbitrarily different IDs for every instance of it. Like, okay, I had to do integer I for the first one, and then like integer like all lowercase for the second one, and something like that. it does just make it much more cleaner than not having to think about up a bunch of like arbitrary variable names. Also, pattern matching for switch allows for nullability in your case statements. So I could also have a null case, and if that made sense, then I could also then have that execute on something. And we can also put multiple labels within a case if we want to have it match on multiple things as well. But then what's also nice with pattern matching for switch is it can actually read in the sealed class hierarchies. So going back to a sealed hierarchy I made earlier with the interface, the user interface, is this switch then can say like, okay, only admin, guest, and customer are able to implement the user interface. And here on this switch, I'm switching off on user, and I'm covering admin, guest, and customer. The compiler can realize that this switch case is exhaustive, so I do not need a default case here. But what's also nice, to go back to maybe making things a bit safer, is, okay, if maybe initially I only had the admin and customer user types, and then later someone went and added a guest user or guest implementing user, then this will give a compiler error because this switch case, or the switch expression is no longer exhaustive. So that can be very helpful in not accidentally, again, introducing bugs because a change was made in one area and then that developer didn't know or think to also then update perhaps the switch case. Now their code just simply wouldn't compile, preventing error from reaching production. I actually need to make an update to this slide deck. So initially, record patterns and array patterns, they were part of the same JEP 405, but they have since been split. Right now, only record patterns are part of JEP 405. It's currently in JDK, or currently in candidate status. Hopefully, it will be in JDK 19. It's not officially part of JDK 19, but good chance that it will actually be there. So what record patterns are is, so here we can kind of see like an example of like, we have like this long if chain, if else block, and we just want to get to one specific field that's kind of deeply nested within this class hierarchy. And so first we would need maybe perhaps to check that rectangle isn't null. Okay, if it's not null, then we'll get a field out of it. Okay, if this field that we just got out, is it not null? Okay, it's not, then we can reference our field within it to make sure we're not getting null pointer errors. But with record patterns, and pattern matching, for example, with pattern matching for instance of, it will also, just by the fact that rectangle isn't null, that's the only way it could be an instance of rectangle. So this handles null more safely and more cleanly. So we can just then directly reference rectangle R within the if block. And we can further enhance that. We could also then do the same for color point UL within that other if statement, if as well. But what record patterns allow us to do is to also directly reference fields within that record. So here, if instance of rectangle, is a rectangle, then I can directly reference, for example, the fields or the components of that record, like color point of UL or color point upper left or color point lower right, and then reference that as well. And again, by pointing that out, it will also check to make sure that it isn't null, like that's the only way it could be assigned. So what we get is, and we can just farther go down that chain of, instead of point out the color point of which that class we're trying to get to the color of it, we can just instead chain these together and we get something that's much cleaner and easier to look at, defining in a single line what was being defined in about 7 or 8 lines before, and then we also don't have to worry about any sort of null pointers occurring. Array patterns, and again, this is in a separate JEP, and actually I know know if it's in candidate status, but it is something that should be eventually coming. So we have an array here just with a couple of values. And instead of doing the square brackets and then referencing like the item within the array, we can just simply reference directly the elements of that array and assign a variable to them. As we're, in this case, I'm referring to the first and then second element with the S1 and S2. And again, we get the null checking as well, because for the instance pattern matching to succeed, by definition, it can't be null. This can also work with multi-dimensional arrays, where, you know, if I have a two-dimensional string array, I can then just refer to nesting down within the arrays to the elements I want to pull out of it. So also with record patterns, they can also build in with array patterns or switch patterns. So here in this case, again, referring back to that earlier user hierarchy I made, I can have my switch expression, and then it can say, okay, if it matches on the admin type, then refer to get the string access element out of it, and then I can then use that in the right side of the switch label to do whatever I want with it, or I could also use it within a guarded clause to do some additional checking on it as well. Here we can also see how we're using the var type, so we don't maybe have to worry too much about the different types of fields, because like here, for admin, it's using a string, for guest, it's using a string, but for customer, it's using an int. I can just simply label these as all var, and then let the compiler kind of handle that as well. So a bit further out, this is where definitely don't take anything specific syntax, as it will most likely change. But we can see farther enhancements to arrays where, so like right now with the example of the array patterns, like I would have to kind of know the specific elements within the array, and particularly also if there's like a really large array of like several thousand items, you know, I wouldn't want to have to necessarily go like S1, S2, S3, you know, all the way up to 1,000. That wouldn't be really practical to get to it. So instead, we can reference like the length of the array, and then just say, okay, I want to get out like the second to last item of the array and set that to the pattern variable of X, and then the last element of the array and set that to the pattern variable of Y. And, you know, I can then do that with whatever, but that can be very good if, again, you want to get to, you know, the last item of the array, or maybe you want to get the median item of the array as well. That would make it much easier to navigate. There's also the idea of maybe don't care patterns. So in this example, you know, I'm checking to see if something is a point, and really the only value I care of getting out of it is the X value. I don't care about the Y value. So maybe we will allow ability just to put an underscore to say like, okay, I don't care about this value, I'm only checking for this one. Or it may just be simply a case you just reference the field name matching of it just to pull out, okay, I only want the X out of point. Get that to me. I don't care about any of the other fields within it. The other could be pattern matching or another item is pattern matching in for each loops. So of course we're familiar with the for each loop where, you know, we're looping through, and like in this case, an entry set. And we assign it to the value E, but then we have to get like E.key and E.value to pull the values out of it. So instead, we could just simply do like map.entry and then say, okay, give me the key and get me the value out of it more directly, instead of having to do that within the body of the loop itself, which again then allows you to know when just looking at this loop to say like, okay, within this loop, I'm interested in the key and the value. You don't have to then read into the loop to kind of get an idea as to what the data is you might be working with. So there's also early access builds. So the early access builds for 19 has already been available for some now. So you can go and check that out. So you can want to see eventually maybe when the third round of preview for switch patterns being merged into mainline, You can check that out then. Also for Loom, Panama, and Valhalla, each of them are all getting increasingly close to actually also making it into the actual main line of Java. You can get an idea of what it will look like. And also we have our new GitHub action, which also allows it really easy to check out these early access builds. And it can then be good if you're doing some automated continuous integration to maybe set up like a nightly build or probably weekly build or something like that to maybe bring in some of these other Loom, Panama, and Valhalla to see how your code might behave or how your applications might behave with these other projects that we are working on. So with that, thank you for attending, and I'll be happy to answer any questions you might have. Yes. Yes. I believe that would only be within the context of the pattern. So it's kind of like a yield where it's only in the context of that where it would be a keyword, yes. So yeah. Yeah, that was kind of one of the things, I think, to better delineate the guard pattern from the pattern variable match. Yeah, that's like the big change that was added in pattern matching, or the third round of the preview for pattern matching for Switch. Mm-hmm. Uh-huh. Yeah, so that, and again, this stuff is farther out just to kind of get an idea. So like a lot of this stuff could change. So yeah, initially with array patterns, something that's a little bit closer out, like you would have to kind of, what you're mentioning, is like you would kind of have to have a really good idea of how all the elements are structured within that array, and also would probably want to be like a small array you're working with, because otherwise it would be very laborious to kind of work through it. And this could also be part of the reason why, no doubt was, part of the reason why record patterns and array patterns were separated to two separate JEPs, because this could probably be worked on a bit more. But again, a bit farther out, you could have like an enhanced array, wherein you can kind of reference the elements of the array, kind of like how you currently do in those square brackets, and then assign it to a variable. And then that could also be a way of like how you can get to like the middle element, the last element more easily. Yep. Your questions? Any others? Or again, also, oops, too far. Feel free again to reach out to me at my Twitter at Billy Korando, or email me. And again, the link to this slide deck is at my GitHub URL.